This video is part of a series focused on developing plugins for microdrop. If you haven't already, please check out the first video in the series, which describes how to configure microdrop to load plugins under development for testing. I will include a link in the description of the first video of the series. In this video, we're going to take a look at an example plugin which demonstrates how we can wait on interactive GTK UI code within the execution of a step. And to do that, we'll look at an example plugin that's published on the Sci-Bots GitHub organization under microdrop.wait-for-ack-plugin, or wait-for-acknowledge plugin. And the implementation of this plugin, it displays a prompt on every step that's executed to wait for the user to click OK before continuing. But you could easily modify this code so that it would only prompt the user in certain conditions, or would display some user interface code that maybe only when that window is closed the protocol would proceed, etc. So this can be modified to your needs, but the basic form should be similar. So let's look under init for the implementation of this plugin. So this is very close, the main structure is close to the minimal plugin that was shown in the first video of the series. The main difference here is the name of the plugin and the handling of the on-step run coroutine callback. So in this callback, we have an inline function called acknowledge, and I'll get back to what that's doing in a minute. So we define that inline function. We log a message just to say that this plugin is handling the step execution request. And then the next statement here is an asynchronous yield operation. So this yields control while it's waiting for the response from this coroutine. And then only when that response comes back do we handle the response and exit the step. And so really the main functionality is in this acknowledge coroutine, which holds up completion of the step until this coroutine has finished. And so now we'll return back to this definition of this inline function coroutine. And so first of all, let's ignore the decorator for now and just look at what this function is doing. So first of all, it's getting a reference to the microdrop. So if we look up here, we imported microdrop as MD. I'll make the code a little bit bigger here just so it's easier to see. Yeah, we imported microdrop as MD, and then down here we're using that microdrop reference to get the get app function to get a reference to the microdrop app instance, and then we're getting a reference to the main controller window, and that's so that we can set the parent window of a dialog to the main window. Next, we create a dialog object with OK and cancel buttons. We set the message to be click OK to continue or cancel to stop protocol. We run the dialog, and then once the dialog has returned a response code, we destroy the dialog and return the response code. Okay, so that's pretty straightforward, but the issue here is that the on-step run coroutine is being executed in a separate thread from the GTK GUI. So this on-step run coroutine is not being executed in the main GTK thread. So we need to run it using GTK thread safe, which will schedule it to run in the GTK main thread. However, if we do that, we want to wait and hold up the execution of this step handler until this function has responded. So typically, if you just use GTK thread-safe on its own, this would get scheduled to occur sometime later in the GTK main thread, but the call to the GTK thread-safe would just be scheduling it. And so it would return immediately, this function would exit. So the way that we can get around that is by using this sync decorator, which is from the async IO helpers package. And what that does is it wraps a call to this function, assuming that you're passing it a decorator itself that will schedule the corresponding function to be called at some later point in time. But then the sync decorator then wraps that whole execution and waiting for the response as an async IO coroutine. And so we can, what effectively it's doing for us here is it's allowing us to synchronize and coordinate the UI execution within the step run coroutine callback, which is running in an async IO event loop in a separate thread. And so by doing that, we just add this decorator with GTK thread-safe, which indicates that call this function by scheduling the execution using GTK thread-safe, and then synchronize it to wrap it as a coroutine so that we can call it as we do on this line, where we're using the async IO.from and we're calling this acknowledge coroutine. This will then cause the GTK window to be launched in the main GTK thread, and then the coroutine will yield until the dialog has been either accepted, OK, or canceled. The result of that yield will then be the response of that GTK dialog, and if it's not OK, then we will raise a runtime error, which will cause microdrop to halt the protocol, or we will simply log a message saying that the user acknowledged the step completion. And so here we're demonstrating this GTK UI code to just pop up a dialog and ask for a user to click either OK or cancel, but this could be any other UI code as well. So you could have already had a window open and you're just waiting for some status change in that window, or you may leave a window open and you want to show some results while you're measuring values from a sensor or something. You may want to plot the output, and then once the output of a sensor reaches a specific value, then you can return. But regardless, if you're doing any UI code, you'll want to use and want to block the execution of this handler until that a certain UI event has completed. You'll want to use something similar to this. So the async IO helpers sync decorator, and passing it the GTK thread-safe as the mechanism to schedule the corresponding function to be run. Now, here we will just demonstrate the operation of this plugin. So from the past videos in this series, you can see that we've already got some contents in our microdrop development plugins root. And so then the next step is we'll just clone this repository to add it. Clone. And again, similar to what we did for the Dropbox Signals plugin, we want to clone it, but not to the default name. We want to clone it to a valid Python module name. So in this case, we'll replace the hyphens with underscores and drop the microdrop prefix. So wait for ack plugin. And here we can see that we've successfully cloned that plugin. So next we'll launch microdrop. And again, this plugin isn't particularly useful in practice because it's going to pop up this dialog on every single step. So typically you would only want to pop up the dialog under certain conditions. But this is just for the sake of example. So we'll look under the plugin manager, so manage plugins, and we see we've got our wait-for-ack plugin that is showing up here. So we'll enable it. And now if we click play, we'll see that we get this wait for acknowledgement dialog. And you'll see that the protocol is held up here until we do something. So if we click OK, the protocol completes. If we add another step and click play, we'll see that it pops up once, pops up again, and then we can click OK for it to continue. And just to show what happens in the error case, so if you click cancel, then you get a corresponding error to say that the protocol was stopped due to that cancel error happening. So this would occur if you raised any type of exception in your on-step run callback. So in this video, we demonstrated how we can wait on interactive GTK UI code within a step to hold up the protocol for some UI event to occur.